Okay, we start with question number 1. Start the class with question number 1. What's happened with the chat? Slideshow. Okay, post model paper. Okay, we start with question number 1, which is the following equivalent to the what? What? Which is equivalent to what? I think usually we use a P power equals to, or what power equals to force times with the displacement Fs divided by time, or we can use a W equals to we can use its dimension, which is W equals to joule per second. This is actually how much the energy over the time. Actually, same equals to the power joule over time. So we have a joule per second. Then we have a joule is actually nm. So
Per
times with
second.
1.
Per second. A, sir.
Okay. So answer is A. Correct.
A.
Neglecting a resistor, the motion of projectile motion has horizontal component and vertical component. Which statement correctly describes two components of motion? Okay, so you know the horizontal component will be horizontal is left to right. Left to right is horizontal. Vertical we have up and down. This is vertical. So left and right we don't have any acceleration. There's no any acceleration. Meanwhile vertical we have acceleration, and that acceleration we call as gravitational acceleration. So G will be the acceleration. So negative G essentially is the constant with the constant of negative G. So the answer is
B.
B. The answer is B. So number 1 A and number 2 is B. The third, the graph show below the change of momentum of a body with time. So what is the quantity presented by gradient of the graph at a particular time? The gradient is you know the gradient equals to
momentum over time.
momentum y1 over it's a change of y over change of the x. So it's a this is what we call a change of momentum divided by change of time. Okay, so velocity of body is not gradient of velocity of body. It's also not impulse of the body, and instantaneous force of the body. It can how? Because force is actually change of momentum divided by change of time. So it's actually instantaneous force of body. Instantaneous kinetic body is not. Okay, answer number 3 will be C. Okay, number 4. Who has done this one? What will be the answer? Which one is the answer? Which is the answer number 4?
D, sir. D. D, sir.
D. Others? How about others? How about others?
Oh, you mean us? Yeah, D.
D. Okay. So actually it's a ratio. Okay, given by F equals to KV squared. So F1 over V1 divided by F2 equals to KV2 second. So this is number 1 and this is number 2. So we divided it F1 over F2. F2 equals to divided K. Cancel the K and we have V1 squared over V2 squared. Okay. We have the numbers for F1. Substitute F1. F1 is 600. So 600 divided by F2, which is V1
F2.
V1, and this is uh, this one will
15
be
square.
F1 is the 15 squared divided by 30 squared. So we can place all actually make a bracket and place with squared. So F2 is actually 30 over 15 squared times with 600. Okay, so you have found how much is the force needed to overcome the resistive force. So F is actually 2430 Newton. This is only the force. Now we need the power. How much is the power? Power equals to force times velocity. So force is 2400 times velocity at that time is actually 30.
30.
So there we have 72 kilowatt. So answer is D, donkey. Any question on question number 4? Anyone? Any question? Gerard and
Okay.
Jeremy still not here, right?
Wait, sir, wait.
Gerard and Jeremy still not here. And when I will put their names on the school administration. If I check back, I think Gerard also not coming for 2 or 3 times already. Because absent. Okay. Any question? So actually it's a ratio. It's given the formula F equals to K times V squared. So it says that the faster the car is moving, the higher will be the resistive force. But it's a force equals to kv squared. So V equals to F over K square root. Okay, so F is actually very small compared to the how much is velocity. So by ratio F1 over F2 K V1 squared over K V2 squared, and we can cancel up the K, and then we have F1 over F2 equals to V1 over V2 squared. From there we can have the how much the value of the force. Okay, when the force when the car has a speed of 30 meter per second. From that we put it into the equation of the power, then F equals Fv. So then we have a calculation over here, then we have a 72 kilowatt needed to overcome the resistive force. Okay, hello all my students, are you there?
Yes, sir,
Hi,
yes, sir, yes,
sir.
sir.
Okay,
Yes, sir,
I
yes,
don't want
sir.
to
We
bother
here.
you when you
Sir,
were
we
talking,
here for
sir.
you, sir.
no, I
Sir,
need
we
some
here for
response.
you.
I need response.
Sir, we
Either
It's
you
here
okay,
for you.
sir.
understood
You're
or
only,
not.
sir.
Sir, we here, we here.
Either I
Understand,
understood or you're not. Okay, number 5. What will be?
Hold on,
B,
sir.
sir.
Ah,
B. My answer is B.
B,
C, sir.
C.
Huh? C?
Let's see other person.
Yeah, I don't know. Day.
Okay,
Nice lah.
answer is C actually. Answer is C. Okay, how do we know? How do we do this kind of question? So first one, we draw a bigger one. This is P, and this is a Q.
Oh, that's opposite, right? Oh, no
This
wonder.
is degrees. Okay, and then it will be uh it will be continuing to falls down. So you can see that I'm going to draw a force diagram on the on the on the string. So the force will be here, okay, because there will be a pendulum that is pulling the force, so tension will be going up. So circular path and point Q is tension. So at this Q, the MG pointing down, right? Right, it's pointing down. It's not going to other way. So now we have to find what will be the degree. Okay, how much is the angle over here? So at this side, actually it will be 30 degrees. Okay, 30 degrees. How we got 30 degrees? Okay, how we got 30 degrees? This is 60, and this one will be This one also will be 60. Okay, pulling downwards we have 90. This is 60, 60. Pulling downwards over we have 90 degrees. So 60 and 90 we have 30 degrees. So that's why we have here 30 degrees. Can you see or not? Can you see? Or the screen is too small?
Yes, sir. Yes, can see, sir.
Okay, so you can see how I get 30 degrees. So there you have here, there are forces, two forces acting, one is pointing up, one is pointing down. Okay, because the acceleration is pointing here, towards the center of the centripetal. Okay, so F equals to ma, and then we have how many forces acting on the string? We have two. So because t is same direction with the acceleration, so t is positive, minus if mg cos 30 degrees equals to ma is the centripetal force. So we can turn it into mr omega squared.
Omega. So
R
that one
omega.
omega, right? Sir?
Yes, it's omega. Mr omega squared. Or usually we have mv squared over r, right? Actually, mv squared over r is equivalent to mr omega squared. Okay. So from there we have mg cos 30 essentially is equals to, who knows? Cos 30 equals to is equivalent to,
Sine 60.
yeah, is equivalent to sine 60 degrees. So t equals to mg sine 60 degrees plus mr omega squared. So answer is C. Okay. Hello? Okay or not? You need time to understand?
Answer.
Okay, sir. Okay, sir.
If you need time to understand, I can wait. I can wait for you. Or you need more explanation, also I
So
can
wait,
explain.
so wait.
Yeah, I can wait. Never mind.
Joe, can I ask something?
Yes.
T minus mg
Cos
cos 30. How
30.
do you get again?
T minus mg cos 30. Okay.
Yeah.
From here. This is T. Okay, over here will be, this is mg. You see, this is mg. So this one will be mg cos 30. This way. This way will be T. This way, or the opposite side, will be mg cos 30 degrees. Pointing downwards will be mg. This one will be 30 degrees.
Shut lah you.
Oh, who you asking to shut?
Wait, why suddenly call so shut?
That's why.
Shut
People teaching you, you know.
Hey, you shut lah, Janice.
I think it's telling other people, not me.
Oh, sorry, teacher.
That's
No,
why.
not
Mute
teacher.
yourself before you
I
say
certainly
something.
on some my.
Okay.
Bugger.
Thank you, teacher.
You need any more explanation? So T pointing up, mg cos theta pointing down. Actually, mg is pointing downwards directly. So on the right side will be mg cos theta. Okay. Hello.
Okay, now Janice. First we ask you to shut now. I don't
That's why.
understand.
Aiyo.
Ask him to shut up lah, ask him.
Okay, say okay.
Sorry, teacher.
Okay.
Okay, teacher.
Okay, number 6. This is very easy. Answer? Answer will be
C, sir.
Yeah, answer is C, correct. You need to derive. You want me to derive?
I want.
You want me to derive? You need or not? Actually,
Can also, sir.
it's inside the book. Actually, okay.
Your wish,
Yeah,
sir.
sir. The
So-
Saspadi one, right, sir?
So you have an object. Let's say you have an
You-
object to be
you
released.
like-
To be released to the outer, where we have this is R with the radius over here. Okay, this is all because of the energy. Is energy, potential energy. Potential energy. So this is R, and then will be at the very far will be R equals to infinity. So we want to throw something which has very high potential energy and release to very far away. We have zero potential energy. Okay, so this at this point will be zero potential energy. Okay, and at this point we have actually when we release we need a kinetic energy, right? Kinetic energy to release with a certain velocity to shoot up this object to the uh, r, I mean very far away, where is r equals to infinity. Okay, so conservation of energy, it says that energy before equals to energy after. Okay, so before we only have half mv square, minus which is the energy over here. So we have half mv square. uh, this is what we call the velocity, escape velocity, ve, uh, plus no, equals to 0. It means that it's very far. This 0 means that it was energy at here, very far away. Okay, minus with the energy, where is the blue marker, with the energy which is at the surface, that is negative gmm, big M small m over r. Okay, so from here you have m over small m, you have small m over here, and then this is r. If you reshuffle everything, you have ve equal to square root of 2gm big M, because small m has been cancelled, over r. Okay, so that's it. Any question? So you see, this black, I mean the red one referring to energy at the outer space, and this is referring to the energy at the surface of the earth. Okay, so how much energy needed in kinetic? There you have half mv squared.
Okay, sir. Continue.
Why 0? Who knows why 0?
Infinity, sir.
Yeah,
0.
because r is
First, the
infinity. It's
don't-
very big, right? So it came from g m over r, and the r is too big, right? Infinity. So the whole thing over here is near to 0. So that's why we have 0. Okay, so v is equals to square root of 2gm over r. Next, question number 7. What will be the answer? What will be the answer? Question number 7.
Second letter alphabet, sir.
So B. Is it B?
Hey, tell properly lah, Tom. Aiyo.
Is it boy? Is it boy?
Yeah, B, sir. B.
Others? Do you have another answer? Who's in the class? Maverick? Oh, Maverick. Janice?
So I'm here, sir.
Janice?
Say lah, shut up.
Sir, he shut today.
What's your answer, Janice?
Boy.
Boy.
Yes.
Nick?
Same, teacher.
B. Okay. So okay, we know that we have to separate them into x and y. For x, for the x, we have 75 x. Okay, y we have 75. The x-axis, this we are going to see in this direction. In the x-axis, we have the whole thing. The whole thing is like this one is the whole thing is 100. 10 times 10, 100 minus with this white square. There is 5 times 5, 25. So that's why we have 75. So the whole thing is 75x equals to 50, because we are watching we are viewing from x direction. 50 times 2.5. 2.5 is on this point. Okay, this point 2.5 plus the second square. The second square is 25, 7.5. So it is 2 point of mass, 1 over here plus 1 over here. Okay, and we have x equals to 4.2 centimeter. For y, okay, for the y, I want to erase this one first. Actually, it's same thing. Okay, so we are going to see in the y direction.
Sir, can I
This
ask a question,
way.
sir?
Yes.
50 times 2.5, right? That is the rectangle, right?
This rectangle.
The bottom. Oh, that one. So and then like 25%. Okay, I understand.
This point. This middle. Okay.
Yeah.
So we are watching in this direction for y. So we have over here actually same thing, 75, because the whole thing is also 75. Y equals to, first we see 50 times 5.0. So the whole thing is 50 and the middle is 5.0 exactly in the middle, plus with 25 divide times with 2.5. So it's over here 2.5. So you have to see two direction. One is an x direction, one is a y direction. So y will be equal to 4.2 centimeter. So that's why you have boy as the answer. Okay. So actually, if you point out 4.2. So over actually is how to do this? Okay, if you point at this 4.2 and 4.2 of centimeter over here and 4.2 over here, you put a pen over here, it will be balanced. You put a pencil, the thing will be balanced on it because of the center of mass. Sir, can you explain again? Okay, Lee asking me for explaining again. Okay, again. So the x, we have 75. Because the whole thing actually is 75 is 100 minus this white square 25, we have 75. So that's why we have 75 the whole thing. In the x direction, I mean in the x, when we view in the x, we see that there will be this box first. Okay, this box is 50. You can see that it's 5 times 10 is 50, and the middle of it, in the middle of the x is 2.5. It's between 0 to 5. Of course, it's 2.5 over here. Plus, with another box over here, okay, is 25 because 10 times, no, 5 times 5 over here, we have 25. And the middle one is 7.5. Middle between 5 and 10 is 7.5. So, divide everything, you have x equals to 4.2 centimeter. This is for x. Okay. For y, have to erase again. For the y, we have to see in the y axis. Y axis, first of all 75, of course the whole thing is still 75. 50 times 50 in the y axis, we can see there will be this one first. Okay, this one first. But we have 5.0, it means that in the middle of it, it is 5.0 there in the x and in the y. Plus with 25, the second one. Okay, so this one will be 25 and the middle will be 2.5. So that's why you add up 50 times 5, 25 times 2.5, you end up with 4.2 centimeter. Okay, answer is boy. So actually the center of mass is at this point, exactly 4.2. Any question? Any question? Lee?
Nope.
Okay. Oh, we have 7 more minutes. Number 8, a uniform rod of length B and weight W is H at the end of PA. P, a wire. Oh, it's a P. A wire attached to other end Q is inclined at angle theta to the horizontal. Which equation correct moments are taken about the end P? So we take P as a moment where it will be rotates the axis of rotation. So this rod P to Q, it means that the rod can be moving up and also can be moving down. So axis rotation at a P. Okay. If you take a P as a point of axis, or we can say axis rotation. So P over here, this is P. There will be two forces. This is W and this is T. This is theta. So the theta tension and the tension that is uh, vertically going upwards is T what? T sin theta or T cos theta?
Sine, sir.
T sin theta. So T sin theta. So summation of torque equals to 0. So W is pointing clockwise direction is negative. Negative W with the length. Remember the length. So length over here is the whole thing is B. So W is middle of the B. So B divided by 2 equals to plus. So T pointing up. This T is pointing up in this way. Clockwise, anti-clockwise direction is a positive. That's why we use a positive here. And T, the force is T sin theta times with the whole the length of the rod, that is B, so equals to 0. Okay, so we have end up with T sin theta B equals to W B over 2. So answer is
Donkey.
donkey. It's a donkey. Okay. Okay. We have only 4 minutes. Everyone, tomorrow we continue this objective question. Next, number 9. Which physical quantity of wire depends the value of Young modulus of the metal? Young modulus of the metal, force, constant, stress, strain, or elastic limit. So the force is actually by Hooke's law is to Ke. Force equals to Ke, and Ke is actually what is it K actually? What's it K actually? spring constant, right?
Stress.
It's a
Oh,
spring
wait,
constant.
where, which question are we?
Number 9.
Oh, yeah, sir, yeah, sir.
Right. It's a force constant. So K is actually Young modulus times with the A divided by L. So K is actually Young modulus times A divided by I divided by L, and E over here you put over the other side. So K equals to Young modulus times A divided by L. So actually F is a force number 9. Answer is actually A, force constant F.
Okay, sir.
Okay. Number 10, two wires the same material, X and Y, and length L and 2L, diameters D and 2D. So we have two wire, L and 2L, longer. One is a small diameter D, and one more is bigger. It's longer and bigger, 2D. The wires are stretched by the same force, F equals constant. What will be the value of ratio of the strain wire X? Now we are asking the strain strain of X divided by strain of Y. So yes, this is what the question needed. The answer the question needed. The value. Okay. So you know the force F equals to Y A gamma. No, is a Young modulus times with the A divided by the L times E. Okay. Same thing we have done in question number 9. So the strain equals to, what is the formula for strain? Extension divided by
E over L is
L by L. Okay, original length. Extension divided by original length. So we have F over Young modulus. Okay, actually A, right? Okay, which is A is actually pi d square over 4. This is actually A, the area. Okay, so and it's directly proportional. Okay, is 1 over d. So because you say the force is constant, this is constant, this one is also constant. How you know force is constant? How do you know the force is constant? This one is constant because it was mentioned in the question. Same force, right? Same force. So F is constant. The Young modulus also constant. Why? Because it says that the same material, the same, because it made the same material. So the thing is changed is D. So strain is the inversely proportional to 1 over D. Okay, so strain of X over strain of Y, okay, equals to 4.0. It's L over D, sorry, it's L over D. L over D. Okay, so it is 1 over L over D. Okay, so X over Y will be 4.0, then answer will be D. Next, number 11. Ideal gas equation written as PV equals to nRT. The symbol N, of course, is answer number A, B, C, D. A, B, C, D.
A.
A is number of moles. PV and RT is number of moles. Number 12. Root mean square of the gas depends on. So actually C, which is RMS, root mean square of the gas. It depends on square root of temperature, and temperature, as you know, okay, is related to PV equals to nRT. You see that this T. So when the
Yes,
temperature
sir.
increase, PV also increase, so it will also increase by pressure and square root of pressure and volume. Okay, so answer is C, pressure and volume of the gas, C. Number 13,
So can I see question 11 again?
question
11.
11, A. Our one was
10, 10. Just now.
10. Answer is 4.
Yeah.
Stress over strain. Strain is related by proportion by L divided by D. Strain is proportional related by L over D lah. Okay.
No.
Okay. Next question.
Okay.
11A answer. 12. C. Square root of PV. Number 13. The temperature of fixed mass monatomic gas X shown in the diagram below. XY and XZ. The heat required to process XZ and XY are Q1 and Q2. So this part XZ is Q1. So this is Q1. This is Q2. What will be the ratio of Q2 over Q1? So it's asking Q2 over Q1 will be the ratio. Now, XZ, X to Z, this is actually constant. We call heat capacity is a constant volume. This is constant volume. Okay. This part is constant temperature. Okay. So for constant volume, we have Q equals to N C
C
V
V
M T1 minus T2.
T2.
So this we call as Q1. This Q1 and CVM T1 minus T2. For Q2 is Q2 equals to NC P M T1 minus this is T2 minus T1. This is also T2 minus T1. So see Q1 and Q2. Okay, so if you minus everything over here, there is a Q1. Q1 is Q1 over Q1 equals to NC VM T2 minus T1 divided by Q2 equals to NCPM. Oh, it's another way around, right? Oh, Q2 first. Q2 equals to NCPM T2 minus T1. Q1 equals to NCVM T2 minus T1 divided by, because Q2 above Q1. So you have minus, you can cancel. So Q2 over Q1 is actually CPM divided by CVM. CPM minus CVM. Have you seen this one before? Equals to CPM over CVM equals to F plus 2 divided by
OF.
F. Now
F.
what is the F over here? What's the F over here? What will be the value of
3.
F? 3.
Wait, 1 the 1.
3.
3. Oh yeah, 3 is the 3.
Degree of freedom. 3 plus 2 divided by 3. You have 5 over 3. So answer is B. Point. Because it's a monoatomic gas. Okay. Any question?
Okay, sir.
Any question? Others? You have any question? Next.
Okay.
Question number 14. Two samples of X and Y are the gas are the same mass, volume, pressure, and temperature. Sample X explain isothermal expansion. Isothermal expansion and twice of its initial volume. Sample Y experience adiabatic expansion twice its initial volume. So both of them explain increasement of twice of its initial volume. Which statement comparing the final state of two samples are correct? Okay, we have to draw first PV graph. For the Y, it says let's say twice initial volume. Okay, this say about the temperature isothermal. Okay, so let's say we start from here. For Y, for X, isothermal expansion. So it drops down here, drops down over here. This is the curve, and the curve is isotherm. Okay, it's a curve like this. How to write? Okay, this way. Okay, this is for sample X. For sample Y, for the sample Y, because it is adiabatic, so it can cross another isothermal curve. So it drops like this. Can you see? So this is X and this is Y. Okay, and I'm going to also write this is the V naught initial, and this is V to V naught. Both of them ended as same volume, twice of its initial volume, and both of them also drops their decrease in their pressure. But you see that if you make a curve, isotherm curve, I mean this a curve with the same temperature, okay, can see that the Y across to another drops down. Yeah, the temperature of the Y drops down to another curve, isothermal curve, isotherm curve. So answer is he says answer is A. The final temperature of sample X here, final temperature, is higher than sample Y. This one will be the answer. Of course, you can see that this is T1. This one will be T2. T1 is bigger than T2 because much more higher than T2 from the curve. Number 15, the last. Okay. One end of uniform metal rod is kept at 100 Celsius. Okay, this is 100 Celsius. And other room is 30 Celsius. Rod are not insulated. It means that the heat can go away to the side of the rod. This statement about the conduction of heat along rod is correct. Okay, the heat flow along the rod is constant. No, it's not constant because it will be going outside. It was not insulated, so the heat will be drops very quickly. It will not be dropping in a constant manner. B, the temperature gradient along the road, the hot end decreases. Of course, this one should maybe the answer. Okay, maybe the rate heat of loss is constant. Of course, it's not because it was not insulated. The drop will be not like this. The drop of temperature Q dq over dt will not drop like this. Will be in a curve. Okay, drop like that. Temperature from the hot and equally, of course not Okay, because everything is in the curve. So answer is B, 15B. Okay, so we have finished up the objective question. Find out how much you have, how much answer you have correct, how much answer you have correct, you're wrong. Okay, so going to stop here. Tomorrow we're going to continue with the structure and essay. If you have a time, we continue with the essay.
Okay, sir. Thank you, sir.
Okay,
Thank you,
sir.
sir. Bye,
Okay.
sir.
Okay, sir.
See you,
Okay, thank you.
sir. See you in Dota. See you in PUBG.
Okay,
Bye.
bye.
Lol.
So,
Yes,
can I explain 14 again?
number 14.
Yeah.
Number 14, which one? You mean X or Y?
Both answer, like, I don't understand how like the volume increase or decrease. Like how does the how you like how do you know that temperature is higher for
The
X?
temperature higher for X. Okay, I'm going to clear all ink. Okay, PV diagram. See, this is a PV diagram. PV diagram. For a same temperature, there will a curve here. We call as isotherm. This is isotherm curve. Means that any points at that curve, the temperature will be same. So let's say over here, this one will be, let's say, 500K. This one will be 300K. So any point over here, you can see that it will be 500. This is 500, and this curve will be 300.
Okay.
Okay, that's a basic thing about PV diagram, PV graph. It says that sample Y explain isothermal expansion. Okay, isothermal expansion. So it says that when you call a process of isothermal, okay, it does not go to another curve. The drops, I mean the process, the gas does not drops to another curve. Let's say this is X. If it goes down, let's say this is a V naught, right? V naught. So it will be if we flowing this curve like this until this point. So this is V to V naught. This is for X. If we follow this curve. Because why? Because it's an isothermal expansion. It does not go to another curve. Meanwhile, for Y, it's explain adiabatic expansion. Adiabatic, okay, it can go to another curve. I mean, it can go to another temperature. So both of them, X and Y, had the same initial point, but Y, when it increases temperature, increases volume, it can go to another curve like this way. So we have n of Y at the bottom.
So what does adiabatic mean again?
Adiabatic means that the process of the gas, heat does not enter and heat does not flow out from the process. Okay. Isothermal means that when the process is undergo, the temperature will be constant. So you have to remember the definition of both of the process. This is very basic of it.
So temperature of adiabatic expansion can change also.
The temperature, yes, temperature can be changed. The thing we call adiabatic is only the Q in and no Q out. There's no heat entering the system and no heat escape from the system.
Okay.
So that's why we have X on the top and Y at the bottom. So of course, X on the top we have higher temperature. T is bigger than T2.
Then how do I know that sample Y the temperature will drop?
Center Y.
How to know that the temperature of sample Y, right? The temperature drop, right? So
Temperature will drop because the volume has been increased.
formula.
It's not formula, it's logical lah. Okay.
Oh, okay. Never mind
Yes.
then.
See, okay, let's say I draw in the logical method. Okay, this is molecules, right, with high kinetic energy. Kinetic energy is higher because they have vibrates. I mean their vibrates is in the small cage like this. When you increase the volume bigger, the kinetic energy will be lesser, and of course, you say the kinetic energy lesser, temperature also
Drop.
There, you can see that temperature is also drop.
Okay.
Okay, but how much the if you compare the drop of diabatic and a drop was isothermal will not change its temperature. It's only diabatic will change its temperature.
Okay, I understand.
Okay, are you clear?
Yeah.
Okay. All these students are they in the class or
So
they?
that one I don't know, sir.
Okay.
I am listening.
I
sir.
okay.
The rest,
I thought you were AFK. Nobody's want to leave the class.
sir, no lah, sir.
Okay. Good
The
for you.
rest I don't know lah, sir.
Which one?
So got so many.
The
I
rest of the
don't know
other
if they
students.
inside or not inside.
Okay.
Yeah, sir, got so many. Whoa.
Yeah, I thought they were AFK. They Jiahao saying thank you. Okay, see you tomorrow with the structure. Make sure you finish up the structure,
Alright,
then we
sir.
discuss. No point if you didn't do.
Okay.
Right.
Okay, sir.
Okay, see you tomorrow.
Thank you, sir.